Okay, we're building an NFT bridge, which means that we can now move NFTs from Ethereum to Binance, from Binance to Polygon, from Polygon to Binance, from Binance to Ethereum, and any other EVM compatible blockchain. Let me show you. Select our source blockchain. We select our source blockchain and we are going to retrieve the assets. Click and retrieve the assets. We get the assets on the wallet. This is the NFTs that I'm holding in the wallet, okay? And by the way, we're gonna move those NFTs from Ethereum to Binance. So let me make sure we don't have any NFTs on the Binance wallet, okay? So right now I am going to select the Binance chain. It's gonna switch myself, okay? Let's go ahead and retrieve again to refresh. Nothing, zero, nada. Awesome, let's switch back. We're gonna select Ethereum, switch network. Let's retrieve the assets. Okay, awesome. Now we are going to select the NFT that we want to move. Which one do we want to move? Let's select 4, NFT 4. We're gonna move NFT 4 from Ethereum to Binance Smart Chain. Select NFT 4. Select the destination blockchain, in this case, Binance. And now we know that we are going to move NFT number 4, this will be token number 4 or ID number 4, from Ethereum to Binance. I know you want to see this live. I know you do. We're gonna build this entire application from start to finish. You are going to build an NFT bridge. You wanna see it? Do you want to see this live in action? Of course you do. Let's go. Let me check the receipt transaction for this particular NFT migration from Ethereum to Binance. There you go. One more thing. Let me check my wallet. You can see the NFT is gone. It's closed. Now let me refresh. This is all I have. Let's switch to Binance Smart Chain. Let's check now. Amazing things can be done if you put your mind, your effort, and your discipline to it. We're building an NFT bridge. This is not just a simple transfer from call. We need to be creative because now we are dealing with multiple blockchains and we're making one call, but that one single call or single function is going to talk to multiple blockchains. But it has to call that in a sequential order because the order is extremely important. We need to make sure that we confirm first that we got the source NFT before we can go ahead and release the destination NFT. A lot of things have been put into this project in order to be successful, but one of the most important things is the security aspect. The security aspect is a must in this particular design because, again, we are working with multiple hops right here. We need to get the approval to move the NFT. That's number one. Number two, we have to send that NFT onto the source custody contract, meaning that I need to be able to confirm that that NFT was deposited on the vault before I can release the destination NFT. I need to hold in custody that source NFT so I can release the destination NFT. Important, security-wise, I need to make sure that nobody but I, as the owner of that smart contract, can call those functions. Because imagine if someone that owns an NFT decides to be smart on us and calls the smart contract directly, and it's able to transfer not only the NFT that was held in custody, but also the destination NFT. So you're gonna have a duplicate NFT. That is a breach, and that will render every single NFT worthless. It will make every single NFT worthless because now you have a copy, and that defeats the purpose of an NFT. An NFT should be unique. What I'm actually doing in a bridge is giving you the flexibility of moving your NFT from different blockchains. But I cannot have multiple NFTs running around because, again, there's only one NFT. I will hold in custody your first NFT, your original NFT, and then I'm going to give you an NFT equivalent in the destination blockchain that you want to work with. Let's say that user decides to sell that NFT to someone else in another blockchain. So I also have to be able to allow that new owner to use the bridge as well if they decide to move it to a different blockchain. So with that, I also have to be able to send the message to all my blockchains participating in the bridge. Hey, this user sold this NFT. We need to update the wallet address across all my custody contracts to let all the other blockchain contracts or vault contracts that NFT token ID 3, now it's owned by a different wallet address. So we have to make sure that we update that. So there's a lot of moving pieces. And also, we need to make sure that no one can talk to that smart contract outside of the bridge, which means that we need to make sure that it's only executable by the owner of that contract. I can go into the smart contract and release the NFT. Now I'm going to have the source and destination NFT, then that NFT is worthless, right? Because you have a copy. So we need to make sure that that's the case. And we know, if you're very familiar with smart contract exploits and hacks and breaches on blockchain, a lot of them are usually done in bridges because there's a lot of variables. Let's say someone sold the NFT to someone else and that new owner decides to release the NFT and he knows that he can call the smart contract outside of the bridge, then that's a problem. So we need to make sure that that's in place, okay? Video number 1, we are going to jump onto a whiteboard session, and trust me, you definitely want to take a look at this whiteboard session and understand, become familiar with it, because it's going to be harder for you to understand the following videos. You need to know exactly what I'm doing step by step so you are not lost. Trust me, there's a lot of moving pieces, a lot, but it's not difficult. I'll make it easy for you. We're going to take a look at that whiteboard section that is going to explain everything step by step, and we'll go from there. Okay, so what we're looking on the screen right now, it's the flow of functions or the flow of actions that I'm going to be performing in an NFT bridge. Don't get scared about this diagram. There might be a lot of stuff going on, but trust me, it's very simple to understand. Let me go step by step so then you have an idea of what we are going to deal with in this video training series. Okay, so let's take a look at the whole flow, okay? It's very straightforward. I access the bridge as a user. So I am a user and I'm going to hold a couple of NFTs and I decide to move NFT number 1, right? So I have NFT number 1, I hit that transfer function. The first thing that I'm going to do on the bridge is to send that approval for all requests, meaning that I need to talk to my original NFT collection and tell, hey, I got someone, in this case, another smart contract, the source custody smart contract, wants to move the NFT from my wallet, and I am approving that transaction. So I'm just going to allow my NFTs to be transferred by the source custody contract, okay? I receive the approval. So now I am going to expect an approval from the user, right? The next thing that I'm going to do is invoke the source custody contract. And by the way, if I don't get an approval, I will decide to stop the transaction right away because hey, the user is not approving it, so we're not going to move any further, right? But else, what we expect is that the user will approve the transaction, the first one, and what's going to happen in the bridge is that we will invoke a function that I coded in the source custody smart contract. That is the smart contract that is going to get that token and store that in the vault. So then we can go ahead and tell the destination blockchain to mint an NFT so that user can use it in the other blockchain. So you're following me. So now when we get that retain NFT function, we call that function onto the smart contract. This is a normal Web3 call. We are going to expect the user to approve the transfer from that token, or execute, I would say, execute the transfer from that token to the vault, okay? So what we're gonna do, I am going to show you right now, okay? So what we're going to do, we are going to expect that the user says yes, right? So the user has approved to retain the NFT. That will be transaction number 2. And the second and only transaction that that user must approve with the wallet. After that, everything will be done by the bridge, okay? Once I get approval and I transfer that NFT, I need to validate and confirm that the NFT has been stored in the source custody contract. I need to be able to confirm that I do have the NFT so that I can go into the destination blockchain and start calling the function so that I can issue a token to that user, okay? Once we get that approval, right, and this is why I'm specifying right here, I have confirm before continue, because this is very critical. If for some reason we issue the new NFT, but we haven't confirmed that we got the old one, oh my God, your day is not gonna be pretty because you basically gave 2 NFTs, one in the source and one in the destination, so you render the NFT useless. You know, it's up to the holder as a good faith to transfer that back to the custody, which it's not going to do. And also you can go ahead and destroy, because you are the owner of the bridge, you can go ahead and destroy that token, right? But again, we don't want to get to that hassle. We want to make sure that we confirm before we move the destination NFT, okay? Obviously, we're going to have the conditions, right? So is the token in the custody contract? It is. Then let's go forward. Now, and obviously I'm not going to explain this. If the token is not in custody, I'm like, you know, stop the transactions. But we have to make sure that we do that, right? Else this could be dangerous, because if you don't have a condition to stop, it could continue issuing the other, you know, NFT. And what very simple or common scenario for someone to test if this is vulnerable is just to cancel the transaction. If we cancel the transaction, the second or retain, but then the blockchain, but then the bridge continues minting or issuing the token, then the end user kept the original token, but also got the token in the destination blockchain. And again, that renders the NFT useless. The user might think, oh yeah, I got 2 NFTs, but in reality, he destroyed the NFT, because I, as the contract owner, I can go ahead and either destroy the NFT or, you know, block that NFT from moving. But again, we don't want to go that route. We want to make sure that we do the proper security mechanisms and we test. So I actually tested, you know, all the scenarios you can think of. Okay, let's continue. So now I got the token minted. Okay, what is this all about? I need to make sure if this is the first time that that user has transferred that token onto the bridge, in the destination smart contract, I'm not going to have the NFT minted. Absolutely not. What I have to do, I have to actually mint on the fly, okay? And I have to mint with the exact token ID. So if someone moved NFT 1000, I need to make sure that I mint NFT token ID 1000, because the functions are going to specifically call the token ID so then it knows to which owner it belongs to. We're still going to follow the same principle as just a normal NFT collection. But instead of an NFT collection being minted in order, like, from index, it starts with 1, 2, 3, and 4, we are going to mint randomly. And you're going to see this, how we do it. It's very straightforward, okay? But we have to make sure that we can mint that token at the destination contract and issue the token to the user. So we need to check if the token has already been minted at the destination contract. If not, we mint that on the fly. We await for the token to finalize the minting, and we confirm that that token has been moved to the vault custody. It cannot be moved to the customer or the client or the user. It has to be moved to the vault first, because I still need to have record that that NFT got stored in the bridge vault contract or the custody contract, right? I still need to follow the process. But then once I confirm that I moved that NFT to the custody contract in the destination blockchain, then I can continue executing the same functions. So that's why I am going to check, is this token ID already minted in the bridge contract? This is the destination contract. If so, owner ID for token ID 1. I need to make sure that if you already minted that token in the destination smart contract, okay, who's the owner? Is it the same as the one that is about to send this NFT? Because if it's not, we have to update this, right? Because we want that new owner to be able to get the NFT back onto the original or the source blockchain if they want to, right? And this is also a scenario where if that user decides to sell that NFT, we need to make sure that we can update this across the board, across all the NFTs that we have deployed in the different blockchains. I have to make sure that I can update the wallet holder, the owner of that NFT across the board. So then if they decide to move it, they can do so. And we can also transfer the NFT to the right owner. We don't want to transfer the NFTs to the previous owner, right? We want to make sure that we transfer the destination NFT to the right owner. And this is why I'm doing that particular call, okay? So let's continue. Now, once I confirm that, right? Once I go ahead and confirm that I am the owner, if I am the owner, just continue. If I'm not the owner, I am going to update the token ID to reflect the new wallet address, okay? After I am done with that, okay? After I am done with that, the next thing I'm going to do, and sorry, this is like on the way, okay? So what I'm going to do now, I am going to call the bridge NFT contract. If the NFT is not minted, I am going to then mint that NFT like I told you previously, right? So if the NFT has not been minted yet, I will be minting that NFT at the destination contract. Again, we got the source contract. This is the original NFT. So we're not making any changes to that. But then that user sent me that NFT to the bridge. I'm holding that in custody. Let me give him an NFT at the destination blockchain, which in this case is Binance. I am going to verify. Have you already moved that NFT to Binance? Because if you already moved that NFT to Binance, I don't need to remint. I already got that NFT. And it's on the vault, because if someone minted and moved to Binance, but is trying to use Binance again, that means that that NFT was already minted and it's already stored in the vault contract. You see where I'm going? In custody. I'm still holding it in custody, okay? So if the scenario is no, let me change this color to be like, yeah, this one should be good. Okay, if the answer, do you have an owner ID token 1? You don't. That means that the NFT is not ready. or it's not available, then go ahead and execute a mint function. But this mint function is going to be called mint. It's going to be called bridge mint, meaning that I am going to invoke my bridge NFT contract. This is different from the regular smart contract, and I'm going to mint the NFT. The only difference, this bridge mint function can only be called by the owner of the bridge NFT collection contract. Because again, I don't want anyone to call this contract and mint NFTs. Only the owner of the contract itself can mint. How are we going to accomplish this? We are going to accomplish this by storing the owner wallet of that smart contract. This is the wallet that we use to deploy the smart contract, and Ethers. So we are going to store the private key and everything. Obviously, it's going to be ciphered, but this will reside in the bridge application. Okay, and that wallet can automate the process because I don't need to confirm or anything. The wallet will be there and will just auto execute those functions. Okay, so using my owner wallet, okay, I am going to request the mint, right? Once I mint that, I am going to confirm that I got the mint, right? And I am going to release the NFT because now I know that I got the bridge contract NFT minted, okay? And I'm holding the previous blockchain NFT. So let me rephrase. After I mint the bridge NFT, this is the destination NFT, I am going to issue to that user, to that owner of that NFT, the NFT in the destination blockchain. Why? I got custody from the source NFT. I got custody, I got possession of that original NFT in Ethereum, right? So in Ethereum, I got possession of that original NFT. I validated and I verified that the owner of that NFT is matching the vault. If it's not matching the vault, I need to confirm that he or she is the owner of that NFT, and I just called the NFT collection. Hey, is this the owner? Can you tell me the owner address? Let me verify to whoever is making this call. It's the same. Go ahead and continue. If I don't have the NFT in the destination vault, I am going to invoke my bridge NFT contract, and I am going to mint that destination NFT. And I'm going to say the wrapped NFT because it's basically the same NFT that I have on the source. I'm going to have on the destination, but I'm going to hold the source. I'm not going to let the source outside because then I have a duplicate, and we don't want that. We need to have only one. It's unique. Okay. Once I get that bridge NFT ready to go, I am going to release that NFT onto the destination contract. Okay? Not to the user. You can see right here where I'm sending that NFT that has been minted at the destination. It has been sent using the release NFT, which is another call in the destination custody contract. But I am going to send that to the custody contract. From there, I am going to finalize the transfer to the user. Okay? Why I need to do this? Because I am going to build a struct in the smart contract that is going to store the wallet address of that user. So when the user decides to bridge it back to the source, like we're going to do this same process once again, but vice versa, I need to have records that that user did this bridge function. Okay? And how do I do that? By making sure that I have a record in the destination custody contract that this NFT has been bridged already. Okay? You see where I'm going? Once I get that, it's the same process. If I go back up, this same source applies to the Binance back to Ethereum. Even though that the Ethereum is the native ERC-721 NFT collection, this applies the same. This is the same procedure in the destination. So if I want to go back onto Ethereum, I'm going to do the same thing. I am going to approval for all. In this case, what contract am I going to request the approval? It's not going to be the original. Remember, we're in the destination blockchain. This is different. This is different from the original blockchain. I am going to send the same approval for all, but in this case, I am going to send the approval to the Bridge NFT contract, which is different from the original. Again, we're dealing now with the destination NFT, not the source NFT. But basically, it's the same thing. I am going to approval for all. I am going to allow in this case, the source custody contract is the destination. We're flipping the roles. The destination now becomes the source. You see where I'm going? It's like literally we're just flipping the table. Same process, same workflow. However, vice versa, right? Once we get onto the videos and I start explaining, I am going to refresh this whole process because it might be a little bit confusing at the beginning. Again, it's not. We're just approving the move to the source contract. Once I approve the NFT to be moved to the source contract, I know that I retain that source NFT. I am going to, using my EthersJS wallet, not the user wallet, the owner of the smart contract, I am going to call the destination blockchain. Hey, guess what? I got a user who bridged the NFT. I got confirmation that the NFT has been stored in the source custody contract. You know what? Move that NFT on the destination because I already got confirmation that he gave me or she gave me the source NFT. Okay, so with this workflow, we have a general idea of how an NFT bridge works. It's literally, I'm giving you a one-to-one exchange. That's all I'm doing. But I have to make sure that I keep custody of that NFT. If you have a scenario where you want to instead give random NFT numbers, but then the same attributes, you can do so. And those cases, when the NFT is transferred back, from the destination to the original, you usually burn the destination NFT, which is like it's a fake NFT at that point. But in this case, we can keep source and destination NFT as long as one of them is on a vault. It's stored on the vault. If no one decides to move it, it's just going to stay forever in that destination blockchain. You, as the NFT owner, you're the only one who can move that, right? However, you cannot just bypass this because this will be called from the NFT Bridge wallet owner or the holder or the owner of the contract, not the owner of the NFT. That avoids people from exploiting the function by calling the main function directly. We don't want that. We want only the owner of the contract to be able to make those calls, okay? Alrighty, let's wrap it up. I know there's a lot to digest, but on the next video, what I'm going to do, I'm going to make the smart contract and we're going to draw, as we type the smart contract functions, I am going to draw a very, very dumbed down version of this diagram. Also, I am going to leave this flowchart in my GitHub so that you can review it once again. And, go over the steps that we talked about in this video. Go over it yourself, draw it out, imagine yourself, start thinking and imagine the process. I click transfer, I got the wallet's asking for approval for all. I hit enter or press OK. Now the bridge is going to get my NFT. Awesome, the bridge has confirmed that it has the NFT. The bridge proceeds to send the call to the destination blockchain. I got an NFT. Go ahead and release your vault NFT to this particular wallet address. All we're doing, nothing else. However, there's a lot of security things that we have to take in consideration, and we're definitely going to work on that. Okay? All right, let's wrap it up for here, and we're on to the next video. Let's build some smart contracts to build this amazing bridge. Let's go. You saw it. We got to definitely do a lot of hops. And then now all the hoops that I had to do on a bridge to allow our users to move those NFTs from blockchain to blockchain, okay? Now you know everything on the logic side. Now how everything works. And this is no different from wrapping tokens. Have you heard about WETH or WMatic or W? That word W is wrap, okay? That means that I am allowing you to use a token that is not native to that blockchain to be used by holding with a custodial wallet which is basically the smart contract. I'm holding you the original token. I'm giving you this one in exchange so that you can use it on that blockchain. If you sell it, if you do whatever you want to do, there's mechanisms to also disable or at least destroy that source NFT or that source token, like burn it, right? So then that token only lives in that particular blockchain. That's one way. The other way, and this is the way that we're doing, we're basically holding that NFT in custody. So if someone wants to move it back onto another blockchain, they can do so, right? So we're gonna do that. On the next video, we are going to build the 2 smart contracts. We're going to build the first smart contract. This is the NFT equivalent smart contract. This is basically the collection smart contract that you deployed originally. So if you already deployed an NFT collection smart contract, we're building the same smart contract with the only difference. Number 1, only the bridge owner can mint, call the mint function, because we don't want anyone calling that smart contract and minting NFTs from it, right? Only the bridge is going to allow minting on that smart contract. And number 2, we are not going to charge anything because it's the bridge. The bridge should be able to just mint for free, and we're going to use the owner wallet, the owner of the smart contract, the wallet, to make that call. And this will be all automated using EthersJS. We're going to store that wallet in our app, and that wallet will make the calls to the blockchain to do the minting, to do the transfer, etc. And finally, we're building the custody smart contract, which is basically an ERC-721 holder smart contract. The only difference is that we are definitely storing some user attributes, because we want to make sure that when the user decides to move that NFT back onto the source blockchain, we can transfer the NFT back to the right owner. That's very important, okay? So on the next video, let's go ahead and let's build the 2 smart contracts that will bring the NFT bridge to life. Alrighty, so that's it for this video. I hope you like what we're doing here, because this is not a simple project, but it's not impossible. And we're here to make this happen. We're gonna do it, okay? I hope you like what we're doing. If you do, you know what to do. Thumbs up. Hit the subscribe button if you haven't subscribed to, and we'll see you on the next video. Boom, let's do it.